Hello everyone, welcome on back to your notes for 8.1 Similar Polygons Part 2. Let's go ahead and let's cover the theorem related to similar polygons. So this theorem says that similar polygons have proportional perimeters. A reminder, to find the perimeter of any polygon, all you need to do is add up all side lengths. All right, so looking back at our statement though, because we see this word proportional, we know that we're going to need to set up a fraction. Technically two, because a proportion is an equation with two fractions. Now, what we're going to write in those two fractions are going to be one side length from one polygon and a side length from the other polygon. Doesn't really matter which one you decide to put in the numerator or denominator. You just need to make sure that they match. So taking a look here, KLMN is similar to PQRS. So because they're similar, we can go ahead and correspond their sides. I'm just going to go ahead and pick side PQ from the polygon on the right side, PQRS. And side PQ is going to correspond with side KL. So those sides are proportional. And this is going to be equal to the perimeter. And I'm going to call this the perimeter of the larger polygon. And then in the denominator, because KLMN is the smaller polygon, we will find, or we will substitute in the perimeter of the smaller polygon. All right, so let's go ahead and let's give some symbols to work with so that we don't have to write out that really long phrase every time. If you take one side from one of the polygons, divide it with the corresponding side of another polygon, this is going to be equal to P for perimeter sub L for larger polygon, divided by another P for perimeter, but this time sub S for smaller polygon. So we're going to go and we're going to use this proportion right here to solve some examples. All right, so in example 4, they tell us that an Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. Logan wants to build a new pool that is similar to an Olympic pool but has a length of 40 meters. Find the perimeter of the new pool. Now, before we begin, we should probably quickly sketch in a picture so we can kind of visualize what it is that we're working with. So in the problem, they tell us that this Olympic pool is rectangular. So let's go ahead and let's draw a rectangle. I'm going to go ahead and call this pool the Olympic pool. And the Olympic pool has a length of 50 meters. So we're going to go and label that in our picture here. And it also has a width of 25 meters. All right. Now, Logan is building that new pool, and it's going to be similar to the Olympic pool. However, it has a length of 40 meters instead. So if I were to compare the lengths of both of these pools, Logan's pool is going to be a little bit smaller because the length is also smaller. So when I draw Logan's pool, I'm going to draw it a little bit smaller. Here we go. This is Logan's pool. And then Logan's pool again has a length of 40 meters. All right, so because the problem is asking us to find the perimeter of the new pole, they want us to find the perimeter of this rectangle here. Now, one way to do it is to definitely go ahead and find the missing side length and then adding everything up. But we can go ahead and we can actually solve directly for the perimeter using the proportions from the theorem. So I'm going to go ahead, I'm going to set up two fractions. One fraction is going to contain the sides, the corresponding sides from each pool. So if I try to use the width here for Olympic pool, I notice how I do not have a width here for Logan's pool. So instead, we're going to go ahead and we will use the lengths of both of these pools. I'm going to choose to write 50 meters in the numerator and 40 meters in the denominator. So when I go in to write the perimeters for each pool, I need to make sure that the numerator comes from the Olympic pool. So I'm going to say PO for Olympic perimeter, and I'm going to say PL for Logan's perimeter. Now, again, the reason why is because 50 meters comes from the Olympic pool, and then 40 meters comes from Logan's pool. Just need to make sure that we match the appropriate measurements in the numerator and the denominator. All right. Now, we actually don't currently know the perimeters for both of these polygons, but I do have all of the side lengths for the Olympic pool. And keep in mind that because this is a rectangle, that means that two of the sides are the same length. So I have 50 meters on the other side, and I'm also going to have 25 meters on the top side. To find the perimeter of the Olympic pool, all we need to do is just add all these numbers together. And I can actually go ahead and do it right inside the numerator here. So taking a moment, the left fraction remains the same. I'm not doing anything with it. So 50 divided by 40 is equal to the perimeter of the Olympic pool. So for this one, I will take 50 plus 50 plus 25 plus 25. Because I'm adding up all the sides in order to find that perimeter. And this is going to get divided by the perimeter of Logan's pool. Taking a quick moment to kind of simplify the numerator there, we're going to go ahead and have 50 divided by 40 is equal to 50 plus 50 is 100, 25 plus 25 is 50, so we get a total of 150 for the perimeter of the Olympic pool, divided by the perimeter of Logan's pool. Now we can go ahead and cross multiply. And so on the left side of the equation, I have 50 times the perimeter of Logan's pool is equal to 40 times 150 on the right side of the equation. All right, so 50 times the perimeter of Logan's pool is equal to 6,000. To finish solving for the perimeter of Logan's pool, divide both sides by 50. 50 divided by 50 becomes 1. And so we are left with the perimeter of Logan's pool, which is going to be equal to 120 meters. All right, and there you have it. All right, so go ahead and pause the video here and see if you can give this problem a try on your own. Alrighty, go ahead and double check over your answers. Again, make sure that you are very careful when you are writing your proportions. Whatever side you decide to put in the numerator, make sure that the perimeter in the numerator also belongs to the same polygon. And then you need to find the polygon for gazebo B, but after that, cross multiply and finish solving. Alrighty, let's go and take a look at example 5. Two polygons are similar. The larger polygon has a perimeter of 85 meters, and the ratio of the corresponding sides is 2/5. Find the perimeter of the smaller polygon. So, here's the difference with this problem. They don't actually give us any polygons to work with, but what they do provide us is the perimeter of the larger polygon. So, in order to find the perimeter of the smaller polygon, we of course, like before, we need to set up two proportions. Now, with these two proportions, one fraction for the proportion is definitely going to have to be 2/5, the ratio that was provided to us. Now, the perimeter that was provided is the perimeter of the larger polygon. So then the question becomes, well, do we write it in the numerator or do we write it in the denominator? Keep in mind that this ratio is from one polygon to the other. So if we think about it, one of these numbers has to represent the smaller polygon and the other number needs to represent the larger polygon. Just through the use of a little bit of logic, because 2 is smaller than 5, this 2 represents the smaller polygon. And so that means that 5 represents the larger polygon. So the perimeters on the other side of the proportion, the numerator is going to be the perimeter of the smaller polygon, so P sub S. And then the perimeter for the larger polygon, P sub L, will go in the denominator to match the fraction on the left side. We're going to take a moment and substitute everything in. So I have 2 divided by 5 is equal to the perimeter of the smaller polygon divided by the perimeter of the larger polygon. Again, they tell us what that is. It is 85 meters. Going to go ahead and cross multiply here. And what we get is 5 times the perimeter of the smaller polygon is equal to 2 times 85. That gives us 5 times the perimeter of the smaller polygon is equal to 170. Finishing this up, we're going to go ahead and divide both sides by 5. 5 divided by 5 becomes 1. The perimeter of the smaller polygon is going to be equal to 34 meters. All right, and there you have it. That's how we can go ahead and use the ratio to solve for one of the perimeters without the need for a picture at all. Go ahead and pause the video here and see if you can give this problem a try on your own. Alrighty, go ahead and double check over your answers. Again, just making sure that this time we're actually given the perimeter of the smaller polygon. So that needs to go into the numerator because again, 3 is smaller than 4. Alrighty, that is it for your notes for 8.1 part 2. Thank you very much for watching.